Hello everyone, my name is Santosh Gupta and this is part 3 of my Arduino video series. In this section I'm going to cover troubleshooting, specifically troubleshooting components of the circuit. You might notice a difference from last time. This time I'm using a flex sensor instead of a photoresistor. So instead of changing its resistance based on the light, it changes its resistance based on how much you flex the sensor. So let's check out the signal we're getting. So I'm going to bend the resistor, and you can see it decrease, the signal decrease as I'm bending the sensor. So what we want to do is check if the sensor is working according to its specifications. You can see I found the specifications of our flex sensor, and so I give specifications for how much resistance it has when it's flat and how much resistance it has when it's bent. And what we can do is we can calculate the theoretical input into our analog using Ohm's law and see if it matches up to we can see how it compares to the actual signal we're getting from our system. So we can calculate the voltage input using Ohm's law. This circuit, the sensing part of the device, it is set up like a voltage divider. So Vin, that's our 5 volt power supply. Z1, that's our flex sensor. V out, that goes to the analog input of our Arduino, and Z2, that's our 10 kilo ohm resistor. So I already set up a notebook to calculate the theoretical voltage going into our Arduino, so our theoretical voltage input for 25, that is the specification for when the resistor is totally flat, 25 kilo ohms. So when it's flat, we should get a input voltage of 1.42857, and I mapped this to the to Arduino's 0 to 1023 range. If you remember from my previous video, Arduino maps 0 to 5 voltages to 0 to 1023, and that's the signal that's received by the Arduino. So after mapping it, we get 292.27, and let's see if that matches up to the amount of signal we're getting. So right now we're getting 287. So as you can see, the flex sensor is totally flat. So I'd say that the theoretical is pretty close to the actual values. So I'd say that the flex sensor is working pretty close to its specification when flat. When it's bent, it can have a resistance up to 125 kilo ohms. So that's what I put into our equation, 125. After remapping it, we get, theoretically, we should get a signal of 75.76. So let's see if that matches up. I am going to bend the flex sensor. I think this is as much as I'm willing to bend it. I don't want to wear it out. But we're getting signals of about, at the lowest, 130 to 140. So I'm not sure. It might be that I'm not bending it enough, but I don't want to wear it out. So I'm going to leave this as an unknown. This is kind of old, so it might be worn out, but overall I'm going to leave it as unknown. But when it's flat, this flex sensor is definitely working according to specifications. Not as much as before, since we've been bending it around a little bit. But yeah, so that's the end of our video. If you have any questions or comments, please leave them. I love all forms of feedback, and I'll see you guys next time.